Welcome back to Smith Coding and Design. In the last video tutorial, we went through how to assemble our soft gel fixtures with our model. Today we're going to begin the cam. So I am going to go up and select 2D face. So we're going to use a facing operation to remove all the stock on top of our model. Now I'm going to select the tool. I'm going to go to my Tormach library and select the Tormach shell mill. We're running at 7,500 RPM, 40 inches per minute, which gives us a feed per tooth at right around 1.3 thousandths. I'm going to go to the geometry tab, and it looks like we are going to cut the full diameter of the stock, which is what we want. We'll go to our heights tab and just make sure that our heights are set properly. So we're going to cut from our top height to our bottom height. Our top height is our stock top, and our bottom height is the top of the model, which is perfect. We want to remove all of the material on top of our model. The feed height, the retract height, and the clearance height look fine to me. We'll now go to passes. Things get slightly more interesting. We'll go ahead and change our step over. So I like my step over to be between 50% to 75% the diameter of the tool. We're going to use 50%, which is 750 thousandths. All right, the next thing I'm going to do is enable multiple depths. And I want to cut in steps of 20 thousandths. And I'm just going to go ahead and use even step downs. The next thing I'm going to do is come over to linking and make sure that I check extend before retract. That way the tool goes all the way off the stock before retracting and taking the next pass. That will limit any type of marks or surface imperfections between the transition between passes. All right, so we'll click OK. The next thing I want to do for safety is always simulate. So I'm going to right click, simulate, and then we'll go ahead and press play. And as you see, we are surfacing the top of the stock without any issues. We just want to make sure here, again, as with any simulation, that we don't collide with our fixture or any other sort of material or device we may have on the table of our mill. All right, that looks good. All right, now that our facing operation is finished, we're going to go ahead and do our roughing operation. So I'm going to go to 3D, adaptive clearing. Again, we're going to select our tool. So I'll go to my Tormach library. I'm going to use a 3/8 end mill, 3 flutes. This happens to be my favorite Gorilla chip breaker. Has the chip breakers, helps relieve tool pressure so that I can mill faster. I'm going to click OK. We're running at 7,500 RPM, 60 inches per minute, right around 2.6 thou per tooth. Because this is a 3D adaptive clearing, Fusion takes into consideration the geometry of our part for us. So we'll skip the geometry tab and we will check our heights tab. All right, so you'll notice our top height is wrong. Since we remove the material with our facing operation, we now want our top height to be from our model top, and we can also change our retract height to be from model top. Okay, everything looks good in our heights tab. Now we'll go to passes. So the first thing I see that is wrong is the optimal load. I want that to be at around 10% the diameter of the tool. I'm using 8% or 30 thousandths optimal load. All right, the next thing I want to do is look at stock to leave. We are going to change that to 10 thousandths. All right, and typically between 20 and 10 thousandths is fine. I could have left it at 20. It wouldn't have made any difference. All right, everything looks good there. I'm going to go ahead and look at linking. Again, everything looks fine. The one thing I will do is the ramp height clearance. We'll go ahead and make that 20 thousandths just in case we perform a helical entry. We won't be cutting so much air. We'll start 20 thousandths above our part. I'll go ahead and click OK. Fusion will generate the toolpath for us. All right, now that our toolpath has been generated, as always, we're going to go ahead and simulate. So right click, simulate. We'll go ahead and press play. All right, so we start by going around the edges, and then we perform that helical entry, and then we just start cleaning out the inside of the ashtray. So all of that looks good to me, and you can see those helical entries there. And if I wouldn't have chosen 20 thousandths as the lead-in, it would have, basically cut air, and it would have increased my machine time. So let's prove that real quick. Let's go ahead and stop our simulation. You'll notice we are at 13 minutes 49 seconds for our estimated machining time. So if I go ahead and we edit this toolpath, let's go back to linking, and let's change this ramp clearance back to 100 thousandths and see how our time changes. So again, it takes Fusion a few seconds here to generate that toolpath. It's doing a lot of math in the background. All right, so now we're at 14 minutes and 9 seconds. So as you can see, it did increase our machining time. So we're going to want to go back in and change that to 20 thousandths. That way we prevent from cutting air and save ourselves some time. All right, so that does it for our first two operations. So now we're going to see the facing and the 2D adaptive clearing being performed on the Tormach, and then in the next video we'll do a contour where we clean up or finish the outside of our ashtray, and then we'll do another adaptive clearing where we take a 1/4 inch end mill and we go in and just clear out the areas that the 3/8 end mill was too big to get into. Alright, so now we're going to perform our facing operation. We're using the 1.5 inch Tormach shell mill. We're going 40 inches per minute. Half the diameter of the tool, which is 750 thousandths width of cut, and our depth of cut is 20 thousandths. So we're just taking it nice and slow, trying to get a smooth surface finish. Again, I'm not using any coolant here, just trying to make the operation as visible as I can using my GoPro. The two brass nozzles you see on the screen are from a fog buster. Again, I just didn't want to get any mist or any particles on the GoPro lens. I think next time what I'll try to do to get a better surface finish is go ahead and turn on the fog busters. Right now they're literally just blasting compressed air just to clear the chips off to try to prevent from recutting them. Alright, now we're getting into our 3D adaptive clearing toolpath. We're using our 3/8 inch Gorilla Chimp Breaker end mill, 3 flutes. We're running 60 inches per minute with a 30 thousandths optimal load, and we're just trying to remove as much stock as possible. Again, the chip breakers make it nice because the chips are smaller, prevents buildup, so that can improve surface finishes or help prevent any type of aluminum chips welding to your end mill. Again, here cutting dry just with air blast. Ran into no issues with chip welding to the end mill. I am in the future going to try some coated end mills just to see if the surface finish is approved when cutting dry. And you'll hear me mention Gorilla end mills a lot. I just find them to be a good compromise between price and performance. For what I do, I can't justify $100 an end mill, so I typically buy my end mill from Schar's Tools, and you can get American-made carbide at a very reasonable price. So if you haven't checked out Schar's, go check him out. Alright, thank you for tuning in. Please like and subscribe, and I'll catch you in the next tutorial.